Today we're going to go over polynomial vocabulary that's going to help you when you're doing adding, subtracting, multiplying, and dividing polynomials. So what is a polynomial? Well, a polynomial is basically a math expression with one or more terms. So if a polynomial is one or more terms, what's a term? A term is just a product of numbers and variables. A product is when you multiply. So for n, 4 times n, 5x squared, 5 times x squared, 3x squared, y to the 4, 9, z to the 9. That seems big, but that's a term. X, negative 4. Wait a minute. The x doesn't have any number, or does it? Yeah, sure it does. It has a number 1, but we don't show that 1. So it's a product of 1 and x. Well, what about the negative 4? It doesn't have a variable. Yes, it does. It could be, we'll use x to the power of 0. What is x to the power of 0? 1. And what's negative 4 times 1? Negative 4. So that's why we don't show there. The smallest polynomial just has one term. It's called a monomial. So all the terms I showed you before are all called monomials. Let's look at how we name polynomials based on how many terms they have. A polynomial with one term is called a monomial, with the word mono meaning one. Here's an example. A polynomial with two terms is called a binomial, with the prefix bi meaning two. Here's an example of that. See, two terms. A polynomial with three terms, what do you think that's going to be? Well, if you say trinomial, you are correct. Again, with the prefix of tri, meaning 3. And here's an example. What about a polynomial that has more than 3 terms? Well, we're just going to call that a polynomial. All of them are polynomials, but only the first 3 get special names. So here's an example of that. Let's take a moment to figure out what would not be a polynomial. Well, if I have a variable in the denominator, that cannot be a polynomial. For example, if I have x squared plus 7 over x, that is not a polynomial because I have to be able to put any number in for x. And in this case, I could not put a 0 in there because you cannot have 0 in a denominator. I also cannot have a variable under a radical. For example, the square root of x plus, say, 3x to the power of 6. Again, I have to be able to put anything in for x, and in this case, I could never put a negative number in for x because you can't have a negative number under a radical and still have a rational answer. All right, now that we've talked about the number of terms in a polynomial, I want to start talking about degrees. And I'm going to start with degrees of monomials. To find the degree of a monomial, just add the exponents of the variables. So here's some examples. I'm going to start with an easy one. X to the power of 2. I only have one variable. It only has one exponent. So that monomial is a degree of 2. Okay, look at the next one. All you do is add the 2 and the 3. You get a 5. So that particular monomial is a degree of 5. Finally, look at this last one. Now, does the 7 do anything for us? No, it's not a variable. So I'm going to ignore that number. And I'm going to look at the 2, the 3. And is that it? Is it a degree of 5? Actually, no. That z, what's its exponent? 1. And so 2 plus 3 plus 1, this is a degree of 6. All right, here we go. Let's look at these two because sometimes they confuse people. We're going to start with the x. It's just like the y we had right there. If you don't see its exponent, it's just an exponent of 1 that can be invisible. And so an x would just be a degree of 1. And then the 5 doesn't have a variable, and so it's going to be a degree of 0. Some people might wonder why. Well, if you remember when we talked about terms, I could put an x there, but the way to hide it is put an x to the power of 0 because x to the power of 0 is 1. 5 times 1 is just 5. But do you see how that relates to x to the power of 0 with the degree of 0? All right, there is one other important vocabulary word I want to talk about. When I do have just a number without a variable, we call that a constant. That term is called constant because no matter what I have for x anywhere else in the polynomial, that number 5 is going to stay a 5. Now let's go to degrees of polynomials. The degree of a polynomial is the same as its highest degree monomial. Take a look at this one. What are the degrees of the different terms? Well, the first one is 4x to the power of 6. That's a degree of 6. The next one is 5x squared. This is a degree of 2. And what's the degree of a constant of 1? 0. So out of those three terms, which one has the highest degree? The first one. And so the entire polynomial is said to have a degree of 6 because its highest term is a 6. All right, what do you think the degree of this polynomial is? Well, let's look at the first term, y. I don't see an exponent, but we know that's a 1, and so that's a degree of 1. What's the degree of negative 6? 0. What's the degree of the next term? Well, I have x to the power of 3, but then I have y, remember, to the power of 1, so that's a total of 4. And then the last one is a degree of 2. So what's the degree of this polynomial? It's a degree of 4 because that's its highest degreed term. You might be wondering, why in the world do we even care about the degree of a polynomial? Well, that's all because of standard form. So a polynomial in standard form is written in order with its highest degree term first, all the way down to its lowest degree at the end. And before I show you something in standard form, I also want to talk about the leading coefficient because that kind of goes together with the other one. The leading coefficient is the number in front of the highest degree term. All right, let's go look at some examples. All righty, here we go. When you are thinking about rearranging the terms, I wanted you to make sure that all of your plus and minus signs become negative and positive signs in your mind, just like that. All right, as a reminder, we just had this one. This was a degree of 1, this is a degree of 0, this was a degree of 4, and this was a degree of 2. So which one has the highest degree? Well, the 4. So I'm going to put that 7x3y. I don't have to put the plus sign in there because we never have to put a positive in front. And then I'm going to go ahead and do the next highest, which is this one, the degree of 2. I'm done with that one. Finally, the degree of 1, and then the degree of 0. Now, I've got two questions for you. What's the constant term? Well, the constant would be the negative 6. All righty. What is your leading coefficient? Well, that's easy. When you put it in order from highest to lowest, your leading coefficient is going to be in front, and in this case, it is the 7. All right, why don't you try this one on your own and then come back and see if you're right. Okay, I've circled my terms and I have listed their degrees. Now, what goes first? The 8 into the 7? Sure. And then did you get 6 into the 6, minus 4 into the 3, minus 2? How'd you do? Is that what you had? Okay, let me ask you this. What is your constant? Well, that's the negative 2. And what is your leading coefficient? Well, since we went from the highest degree to the lowest, it's in front, which is the 8. Well, here's a fun one. This has a degree of 2. This one has a degree of 2. And this one has a degree of 2. So what do I do? Do I just keep them the way they are? Or is there some other secret rule that I don't know about yet? Well, it's not secret, but there is another rule. Whenever you have terms that have the exact same degree, you need to put the letters in alphabetical order. So in this case, x comes before y. So I will start with 9x squared, which that could be xx, because x squared is x times x. And then 11xy. And then finally, the one that only has the y's in it, 6y squared. There you go. Hey, what's my constant? Well, since you don't see it, it'd probably be a 0. What's my leading coefficient? The 9. Ooh, here's another fun one. What is the leading coefficient of this polynomial? Oh, my goodness. What do you think? Well, what is the number in front of x to the power 4 that you can't see? A 1. Now are you starting to see this a little bit better? So look at that. Strip the x to the power 4 off, and what you see is negative 1/5. That's the leading coefficient of that particular polynomial. Okay, one last thing about degrees. Just like I can name my polynomials based on how many terms, I can also name my polynomials based on their degree. So if I have a polynomial with a degree of 0, that means I just have a number, like the 4, and that's a constant. We've talked about that. If my degree of my polynomial is a 1, we call it linear. If you're familiar with the y equals mx plus b, that x has a degree of 1, and that makes a line on your graph, linear. Then if your polynomial is a degree of 2, is quadratic, and you might be thinking, quad, I thought that was a 4. Well, it actually is based off of another Latin word that means squared. So quadratic is highest degree is a 2. If my polynomial is a degree of 3, it's cubic. Degree of 4 is quartic. Now there's a quarter also, so that makes sense. Degree of 5 is quintic. Now I want to make sure that you understand that its degree name has nothing to do with how many terms are in the polynomial. All right, there you go. I've given you all the vocabulary that you need to get started. Go have some fun.